Wow. So I'm Taylor. I'm Daniel.
James?
No.
Okay, so for our project, we started with brainstorming first, obviously. So we started with a wheel shooter, like the past 3 groups did. But we wanted more power, and we were like, why doesn't this go faster? And we weren't sure if it was the actual brick itself, or just like the wheel, the rotations to like the wheel. So we tried scrapping, well, we scrapped that, and then we went to a catapult, which we did not get to work that well. So we watched more videos, and then we constructed our final idea, which was
The rotating arm.
a rotating arm.
Yeah, I think you guys have kind of seen it, where it rotates and the ball drops in and it hits it out. So the initial, again, the same thing with the arm, and we had a motor hook to it, and it was just spinning. And it didn't seem like it was going very fast, and so we had the idea to try and gear it up with the gears, the Tetrix gears. So the arm and the gearing and everything is made with the Tetrix pieces, and then it was really hard to find a way to hook the motor to it, but we finally found a way. But we got the arm to spin a lot faster, and we initially started just trying to drop balls into it, and it seemed like it was, well, okay, let me back up for a second. It was spinning, but it wasn't balanced, because the arm is a little longer on one side, and so the whole machine, the whole structure was shaking really bad. And so we balanced the arm a little better, we put some weight on it, to counterbalance it, and it started going a little better, but it still shook a little bit. So instead of just putting the pieces together, I put in the little black angle brackets, and then the screws, screwing it together. And that really tightened up, made the structure more rigid. And then it still didn't seem like the balls were going very far, so we added a little more weight to the arm, a little more mass to it. And that really made a difference. I mean, it went from a couple feet to halfway across the room. So.
Yeah, our main idea is we wanted the most speed and we wanted the most distance. That was our main goal. That's why we implemented the spinning, because out of all the videos we watched, that's one that made the biggest distance, the biggest change.
So, and then Kevin came up with the design for the ball loader.
We come up we had built the whole machine, but we never knew how the machine, how the balls will be loaded. So we tried designing different ways, how the balls will be loaded into the spinning thing. So we finally come up with a simple idea, one of the motors just pull the balls for a little distance every after 5 seconds.
Yeah, it was hard because the structure was kind of getting tall, and we don't have limited pieces. And our initial design for the ball loader maybe was kind of going up, like a lot of people have designed it to go up and they feed down. We was getting way too high. So Kevin came up with the idea of kind of just making them on a little tray, and then they just get pushed slowly. And I guess it doesn't show it, but here in this picture we ended up with just a little string that goes from the slide over a pulley back to a motor, and it's timed for every 5 seconds. It does another pull, and it just slides it forward and it knocks them off.
Yeah, we started with a plastic arm, but we decided that didn't work as well, so we switched it to what we have now, which is a metal arm, because it hits it harder and it just spins better than what we had before. So here's the program, and we started it so that both go off of a touch. So there's a button that we'll press, and then once it starts spinning, this is pretty cool, James came up with it, but the ball loader won't start until it hears a noise. So once the arm starts moving, it'll make enough noise so that the ball loader will start automatically. So then it'll just push the tray thing by just a bit every single 5 seconds, and then the arm will just be continuously spinning throughout the entire thing. But once we press it again, the arm will stop moving, and then therefore the ball loader will stop moving as well. And the trouble that we had was just trying to keep the ball loader within the 5 second interval, and since we weren't sure like how far exactly it would push it, we had it go a very small set distance so that it didn't over push it and like push two balls off at once or not push it at all. So yeah. Oh, go to problem.
The final.
Oh, we didn't.
Yeah, we-
Okay, well we kind of went over the problems.
Yeah, and then that's our final design.
And then I had a video.
Oh, no, this is.
Oh, you don't.
Well, no, we can, I just.
Fine.
Any questions?
So,
That was a good one.
So the ball loader doesn't start until it's making enough noise
Well,
to tell you that it's spinning at full
We,
speed?
yeah, you can only touch it once, so that was just kind of, well,
So you're waiting until it hits full speed before it?
that was the initial thing, was because it does take a second for it to get to full speed,
Right.
so it kind of added in a little delay there, so.
That's a really cool way to solve it.
Any questions? Yep, thank you.